This is one of the more ambitious electrical projects I've ever taken on. We stripped the entire harness, which was necessary because every wire was red. But we started over. That's why the fuse panel is down here. That's why everything's new. So I thought I might give a video to you guys to help with understanding electrical basics, because I didn't understand this until I started building, and now it kind of makes sense. So let me show you how this worked, because I am pretty proud of it. So we've relocated everything to this side of the fender. He's got his fuse panel here, he's got his switch pros here, his spark controller, and his EFI and his spark controller. Down here we have two separate breakers that control the switched 12 volt and the constant 12 volt, and then we have a separate relay for his starter. So there is no key in this truck. There is a kill switch, and then there is a remote button to start it. So let me show you how that works on the inside here. You guys just have to promise to not steal his truck if you ever see it. There is no fuse panel, there's no relays under here, everything's outside. To turn this guy on, it's this button right here. You'll hear the relays firing, the fuel pump is priming, and now the truck is on. I've got my EFI reading down here so I can see what's going on, and then all the gauges are illuminated. This is my start button off the switch pros. I'm not gonna fire it right now, but that is a momentary push that will fire the starter and start the truck. His lights are all hooked up and working. We got high beams. We've got vintage air. I didn't know what I was doing when I first started building these trucks, and electrical was one of those things that was really, really intimidating to me. But breaking it down into smaller bite-sized lessons has helped me build something like this. So I'm gonna give you guys some tips and tricks and my thought process in when it comes to building electrical, how I like to do it and understand it. So let's go back out front. So we got a kind of a unique situation here in the fact that I've relocated the fuse panel over to here. So that's gonna make it a little bit easier to discuss because we'll have everything all right here. Just keep in mind that you're gonna have a battery somewhere under your hood, but a lot of this stuff will appear under the dash somewhere. So let's just jump into it. The basics of how I understand electricity, and that's what this is, my basic understanding of electricity is, you gotta think of positive charged electrons flowing through the circuits, trying to return to this side. And anything in between the positive and the negative terminal on the truck is something that reacts to the electricity that comes through, whether it's an electric fuel pump, or whether it's a fuse, or whether it's a relay. Each one of these things does something to that circuit. Before we get into what the circuits are and what the devices do, we've got voltage, amperage, and resistance. Those are the three in the triangle. Those are the tripod. They all have an effect on each other. Your voltage is basic. So this is a 12 volt system. Unlike your house, which is a 110 or something, or 220 or something like that. Voltage refers to, I like to think of it as the size of the pipe, but it's actually more referring to like how much pressure you've got. So a 12 volt system has less pressure than a 110 volt system or a 220 volt system. Now, in addition to the voltage, you've also got amperage or currents. That's how much workable energy is flowing through the circuits to do the work on the various devices, whether it's a starter, whether it's a relay, or whether it's a fan. In addition to that, you've also got resistance. So amperage, voltage, resistance. The resistance is what is measured as the circuit, as the electrical current travels through the cable, how much of that electrical current is lost, is degraded. And the longer the run, it's very, very simple when you think about it in basic terms. You've got this copper wire that's made of copper that has an elemental structure in it, atoms, protons, and all that stuff. And then you've got electricity, which is the same thing, atoms and protons traveling through this copper wire. As the electrons from the battery hit the protons and atoms within the copper wire, that's resistance. So obviously, the larger stretch you have, the more opportunity you have for like these collisions to happen and electricity not to be able to get through. Think it's physics. It's really simple when you break it down to a basic level. It's just matter moving through a circuit. So Voltage, amperage, resistance. This is a 12 volt system. You probably won't see anything on the automotive side over 50 amps. In fact, we're starting to see devices taking less and less amps. But on a high charge system like a winch, you may see 150, 200 amps. That's why you will run a dedicated wire directly to your winch, because it's drawing so much power. And then the final aspect in all of this, we've got this battery bank that's supplying electrons that are trying to return to the negative side. And then you've got an alternator, which is delivering current back to the battery. So as that pulley spins, you've got a couple magnets inside that are spinning around from the pulley, and they are interacting and interfering with the copper winding around. So you can see the copper winding within a alternator. As the magnets spin, you get electrons being flung off, and those electrons are delivered back to the positive battery through this guy. So it's really actually pretty beautiful. It's a system that supports itself. It's very predictable. It's very easy to read when you start identifying what the various circuits are. And at the end of the day, it's basic fundamental physics. So you can rest knowing that if you develop a basic understanding of what these devices are and what they do, they will always behave that way. There will never be any surprises or tricks or didn't see that one coming. Electricity always behaves the same exact way. Laws of physics. Let's use this compact area as an example of your truck on a larger scale. Instead of having this under the dash, it's right next to us. So this is the fuse panel, and you guys are familiar with fuse panels. Each corresponding fuse goes to something on here. So you can see I've labeled some stuff on there for accessories that we've put on there. So this gets its power from two different sources. It gets its power from an ignition or accessory source, which is when your key is on, or it gets it from a battery source, meaning that it's always connected. So some of these fuses are energized by this, some of them are energized by that. That's the two types of circuits that you'll see referenced in any electrical schematic. It'll be battery ignition, battery constant. And you can see under your dash, on your fuse panel, you will see an ECMI and an ECMB. That's battery versus ignition for your computer, if you've got a factory square body. So within this fuse box, all the circuits travel and then get distributed out to their various accessories, and each one of these wires energizes a different part of this fuse box. So I have the fuse box out here, the ignition, the prompt to turn on all the switch 12 volt comes from inside and goes to this relay. So this relay is basically operating as a key. When you turn your key, it connects these circuits, which allows all the electricity to flow not just to the battery constant side, but to the battery ignition side too. So that's why everything wakes up. 3 things that you can do to help out Merricks Garage. First, go to my website. Second, go to my Amazon store. Third, click like and subscribe. My website has all my merch, stickers, consulting, and all the products from the roll cage to the light bar to the seat brackets. Also, my Amazon store will have a full list of products I use, recommendations, things I like, and anything you purchase on Amazon, I get a little kickback for, which helps me just keep producing content for you guys. And finally, click like and subscribe and drop me a comment down below. Believe it or not, YouTube pays attention to that, and it makes me feel really good about myself. Starting at the battery, let's move on to what this panel is, because it's got 3 or 4 devices on here that you're probably going to be familiar with. You've got a relay. Ignore my stupid labeling. This is from my buddy, and I just decided to have some fun with my label maker. But what a relay does is it connects 2 usually heavy load circuits without having the current flow all the way back to a switch. So in a traditional setup, like the Chevy headlights, on all square bodies, the battery cable runs all the way through to the headlight switch and all the way back down to the headlights. All that current running through that cable, you get loss of current and you end up with dimmer headlights. That's what a relay tries to fix. You'll see in this situation, I have two hot circuits that are disconnected by millimeters in here. When this circuit in here gets energized, a gate physically closes between these two, allowing current to pass. So I'm controlling it remotely with these two small wires, but I'm able to open and close the circuit right here in this small device instead of the circuit having to travel through the whole electrical system. That's a relay. They're super important. You'll find them everywhere. There's fuel pump relays, there's flasher relays, there's relays for tons of stuff. Moving on from the relay, we get to a circuit breaker. Now, this is a hard disconnect that when it reaches a certain amperage, which is how much electricity is flowing through at that point, it'll trip and it physically snaps open and the gate inside is no longer closed. You cannot pass through, no current is flowing, everything's dead. So a breaker turns off current and acts as like a gatekeeper to anything too high. Now, in addition to a breaker, you're also going to have a fuse. Fuses are smaller versions of breakers that you have to replace when they are tripped. So a fuse will generally reside on an individual circuit. So you'll have a fuse for your horn, you'll have a fuse for your turn signals, you'll have a fuse for your gauge lights. And if there is any sort of short in that circuit for the particular fused device, let's say it's your instrument cluster, if there's a short, it'll snap that fuse. Now, moving upstream on the current, you'll see that these have much larger gauge wire coming in. This is providing all of the battery current for all the 12 volt constant, which is anything that's running all the time. Like when you turn your car off, it's still connected. So we have heavy duty gauges running through this because if something happened in the main harness, instead of one fuse blowing, it would just blow the main breaker. So think of the main breaker up front with fuses down to protect all the smaller devices downstream. This breaker right here, if I trigger it, I should have amperage running all through the circuit and there should be no worries. What? Hold on. Whoops. Okay, so we've covered a relay, we've covered a breaker, we've covered a fuse. Right next to this is what's called a distribution block or a bus bar. There's two sides to this right here. You'll see a negative side and a positive side. This is where I can connect 12 volt circuits to. So instead of having to go back to the battery every time, you can have a distribution bar that basically moves the positive and negative terminals of the battery somewhere easier to access. Now keep in mind, anytime you add length to the circuit's travel, you're gonna lose amperage. They kind of work in cooperation together. So try and keep things as close as you can, but this is a good way to get more real estate at your battery posts. So this is a good indication of what a relay is going to do for you because I have a relay that is connecting my switched 12 volt circuits, so headlights and things like that. Nothing over, I think probably like 40, 50 amps is going to run through this relay. Now, I also can control the starter through the switch pros. And the way to do that is with a starter relay. So this is, you can see the significant difference in the cables. So these are battery cables coming to it as opposed to just 12 gauge accessory cables. This is a relay, just like this is a relay. This is just a higher amperage relay to fire the solenoid, which is down in the starter. And when you hear solenoid, think electric motor, something that, so a solenoid and a starter fires out a starter wheel that engages and spins on your flywheel to start your engine. But the solenoid is the physical electrical motor or electrical device that does the work to make that physically happen. Most of the things we're talking about here are current passing through them. A solenoid is a physical thing acting physically on a electrical circuit. Mental insane asylum, immigrants, transgender surgery.
They're eating our pets.
They're eating our pets.
In Springdale.
My pets' heads are falling off. Anyway, So back to the voltage situation. If you heard something that you didn't agree with or I misspoke, please comment down below. And if your comment is accurate, I will bump it to the top so other people can learn. Understanding the basics is a good foundation to be able to build more and more. So we will get into that in subsequent videos. In the meantime, I've got plenty other videos out there. I'll link a couple up here I think you might like. And also go take a look at my Amazon store. I'll put together a wish list of basic multimeters and a couple of the crimping tools I use, because in subsequent videos, we're gonna get into connectors and crimping and wiring and other things like that. So we'll see you then.